In a world where machines have trapped humans in the Matrix, our hero Neo is given the chance to escape it and save humanity once and for all.
At last. Welcome, Neo. As you no doubt have guessed, I am Morpheus.
It's an honor to meet you.
No. The honor is mine. Please, come, sit. Let me tell you why you're here. You're here because you know something. What you know you can't explain. Do you know what I'm talking about?
The Matrix.
Do you want to know what it is? This is your last chance. After this, there is no turning back. You take the blue pill. The story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill. You stay in Wonderland. And I show you how deep the rabbit hole goes. Remember, all I'm offering is the truth, nothing more.
Welcome to the Construct. We don't have much time together. Humanity as we know it faces an existential threat from artificial intelligence embodied by the man you know as Agent Smith. The only way to stop him is to learn the bane of the Matrix, parametric equations. Let's begin your training immediately, and remember, each problem only makes you stronger.
How was he? 10 hours straight. He's a machine. I know Kung Fu.
Show me.
Question 1. If x equals e to the 2t and y equals sine 2t cosine 2t, then what is dy dx? First step is to take the derivatives, and you would get dx dt is equal to 2e to the 2t, and then dy dt is equal to 2 sine squared 2t plus 2 cosine squared 2t. Then we have to remember our parametric relationship that dy dx equals dy dt over dx dt. And then when we put this all together, we get that dy dx is equal to negative sine squared 2t plus cosine squared 2t over e to the 2t after we do some simplifying. Question 2. A particle moves along the x-axis so that its acceleration at any time t is 2t minus 7. If the initial velocity of the particle is 6, at what time t during the interval from 0 to 4 inclusive is the particle farthest to the right? So this is an extreme value theorem problem. And so first we'll need to get the velocity vector. In order to do this, we simply take the integral of the acceleration vector, and when we do this, we get t squared minus 7t plus c. We then use the initial condition that we're provided to find that c is equal to 6. And then we're given this equation, which we can break up into t minus 1 and t minus 6, which are our critical points. And then when we put these on a sign chart, we put the values of 0 and 4 because there are endpoints on the sign chart. And we put 1 on the sign chart as well because it's a critical point, and 6 is out of the bounds, so we just leave it out. And so when we use the sign chart, we find that the function increases from 0 to 1 and then decreases from 1 to 4, making 1 the relative maximum as well as the absolute maximum, making it so that the particle is farthest to the right at t equals 1.
Again.
A particle moves along the curve defined by the equation given here. And if the x-coordinate of the particle satisfies the dx dt equation for t is greater than or equal to 0 with the given initial condition, find a x of t and b dy dt. First, to find x of t, we have to take the integral of the dx dt equation that we're given. And then when we do that, we get this over here. And to solve for c, we use our initial condition that x of 0 is equal to -4, plug in, and we get that c is equal to -5. Then we get that x of t, when we plug this into the integral, is equal to 2 square root 2t plus 1 minus 5. Then, to find dy dt, what we have to do is we have to use implicit differentiation on the y equation that we're given. So we get that dy dt is equal to 3x squared dx dt minus 3 dx dt. Then we pull out the dx dt, and then keep in mind that x is equal to this right here, and dx dt is equal to this right here. And so we simply plug in these two equations for x and dx dt. We get this final equation over here for our dy dt. Nice try. After losing to Agent Smith, Neo seeks help from the Oracle.
Come.
I need help. I sensed your defeat as soon as you walked into the room. According to my calculations, I see that you're missing a fundamental weapon of the Matrix, the TI-84 calculator. You will find success with this. Here. I won't fail you.
While the war for humanity rages all around him, Neo returns to the Matrix to use his newfound weapon in the final showdown against Agent Smith.
Mr. Anderson, welcome back. We missed you.
Now that Neo is equipped with his new weapon, he's ready to begin the final fight. Question 4. If f is a vector-valued function defined by f of t is equal to e to the negative t cosine t, then what is the speed at t equals 5? Also, determine the distance traveled by the particle from t equals 0 to t equals 5. Well, for the first part, we simply write down what we're given. Then we take the derivative for both the x and y terms and get that dx dt is equal to negative e to the negative t, and dy dt is equal to negative sine of t. Then at t equals 5, we simply plug in 5 for t. And then that's just reiterating what I just said. And then to find speed, we have to remember that speed is equal to the square root of dx dt squared plus dy dt squared. And then if we plug in the earlier functions that we determined, we get that the speed at t equals 5 is equal to 0.9589. And then to find the total distance, we have to remember that the total distance is equal to the integral of speed. And so we simply set that up 0 to 5, and then we write the speed function, the general speed function without the 5 in it like we determined here, but instead put t with respect to t, and then we get that the total distance traveled from 0 to 5, once we plug into our calculator, is 3.704. Given the equations y equals cosine x and y equals 2x, find the perimeter of the region R created in the first quadrant of these graphs. So first, let's go ahead and sketch out the graph, and we get something like this. And so we can break the perimeter down into this section over here, right over here, the curve, the arc over here, and this line. And so, since this is going to be from 0 to 1, this is going to be a straight line with perimeter of 1. And then to find this over here, we simply have to use the distance formula. So square root of x squared plus y squared. And then to find this arc length over here, we find the intersection point, which you can do in your graphing calculator. And then we set the integral from 0 to the intersection point of 1 plus dy dx squared, in which case it would be the derivative of cosine squared. And when you add all these terms up, you get 2.470 as a total perimeter. The final question, question 6. In this question, we're given two parametric functions, dx dt and dy dt, given the bounds from 0 to 3, and we're told that time t equals 2, the position of the object is 4 and 5. And so we're asked to A, write a tangent line equation, B, find the position at a certain time, and C, find the total distance. For part A, what we do is we have to remember the relationship that dy dx is equal to dy dt over dx dt. From there, we can simply set our two parametric functions on top of each other, and then substitute t equals 2. When we do this, we get that the slope of the line is 15.604, and then we can put it in point slope form based on the initial condition that was given to us. For part B, what you need to do is you need to simply use the initial conditions and then use the integral to find the position at a certain time. And so we know that time t equals 2, the x position is 4, and then we find the integral from 2 to 3 that the object travels based on the velocity function, so we take the integral of that. And so we get that the x position at x equals 3 is 3.953. We do the same thing for y, take the initial position, and then integrate from 2 to 3, and we get that the y position is 4.906, for this being our final position. And then to find the total distance, we have to remember that distance is equal to the integral of velocity, and that this right here is the speed formula. And so we simply have to take the integral from 0 to 1, because that's what it tells us, and that would be dx dt squared plus dy dt squared, all given in the function. And then we put that into our calculator, we get that the total distance is 1.458.